So today's lesson is on inequalities, and we are going to start talking about how to solve inequalities instead of equations, which we have been solving recently. The title of the notes is Solving Inequalities Using Addition and Subtraction. We actually won't get to addition and subtraction until we do part 2 of these notes. Right now we're just going to talk about what inequalities are and how we graph what they look like. So before we start, let's just talk about inequalities in general. We use these symbols for inequalities, right? Greater than is this one, and less than, and we just need to make sure that we can remember which one is which because we're going to be reading a lot of these. The other ones that we're going to use today is greater than or equal to. The little line under there means that it could be a number could be greater than or equal to something, and then also less than or equal to. So those are the 4 symbols we're going to be using for inequalities. Let's see if we can write some ways to remember which one is which. So it says write 2 ways you can remember which way the greater than sign goes. So if I pick a greater than inequality, something like, well, 4 is greater than 2, right? We know 4 is bigger than 2. 4 is greater than 2. What are the ways that you guys always remembered when you learned these inequalities, how to remember which one is the bigger one? Remember which way this goes. You guys have told me in the past that you've done like the Pac-Man eats the bigger number kind of thing. So we've got Pac-Man over here, he's eating the bigger number, and that's how you know that it faces this direction, right? Or some people tell me what the alligator eats the bigger number, so you'd have some like alligator critter-ish thing. Yeah, there's my alligator with his little teeth, eating the bigger number. And 4 is greater than 2, something like that. So eating the bigger number, and then some people tell me that they like the pointy end points toward the smaller number. So the pointy end points to the smaller number. The smaller end points to the smaller number. So whatever way you need to remember it, if we read this out loud, since this side over here is the larger side, the eating side, 4 is greater than 2. All right, we'll just get used to using those again as we go along today. The next question here says, how do you graph an inequality on a number line? Now, this is something that we never had to do when we were doing equations. We didn't need to graph solutions to equations because when we got a solution, it was just something like this, x equals 8, right? That might have been something we had in the past. Well, if x equaled 8, x just equaled 8. There was nothing else to it. That was the solution. When we do inequalities, we're going to get solutions that look something like this. X is greater than 8. I'll zoom in a little bit. That could be a solution to an inequality. Does that mean that x is just one number? Is x only 8? No, x could be anything that's greater than 8. So x could be 9, x could be 10, x could be 1,000,000, and it would be a correct solution. X could be 8.364, and it would be a solution. There's actually an infinite number of solutions because you can keep counting up, bigger than 8. So when we're looking at a solution for an inequality, we like to put it on a number line on a graph so that we can just visually see which numbers we're talking about being solutions to inequalities. So we're going to look at how to actually graph those. Before we put the steps right here, how do you actually do it, let's go down and let's talk about this next part. It says, what's the difference between an open circle and a colored circle, or we also call it a closed circle, on the graph of an inequality? So I'll zoom out a little bit more. You can see there's 2 examples down here. There's one where there's an open circle on this number line and a closed circle or colored in circle on this number line. The difference is that if you look at this, what it's trying to tell you is that your variable, we can call it x, could be any number that is not including 5 because the 5 isn't darkened, but it could be any number on the number line that is bigger than 5. That would be your solution. So we would write this as x is greater than 5. Our number that we're looking for is anything that's bigger than 5. And the difference between that and this is that, you see how it's colored in right there? That means that x could also be 5. In this case, it had to be bigger than 5. In this case, x is going to be greater than or equal to 5. So these are the two ways that a number line can look, a graph of an inequality on a number line. The arrow also could go in the other direction. If we had x is less than 5, then our arrow would be going this way because it would be anything that would be less than 5. So that's what we're trying to make our graphs look like. Let's go back up here and see how we would graph it if it was x is greater than 8 right here. So let's talk about the steps that we'll use for that. The first thing we've got to do is actually get a number line on there, right? We have to have these evenly spaced increments so that we can actually be looking at a number line and then make the graph. Now, since we're going to talk about 8, and 8 is kind of our point of reference here that we're referring to, I'm just going to put 8 right in the middle. And then I'm going to make sure that my number line goes above 8 and below 8 in both directions. Since 8's a whole number, I can probably just count by whole numbers. Right? There's no reason I can't count by ones here. Maybe go down this way. So I have 6, 7, 8, 9. That's a good enough portion of a number line for me to be able to see what's going on here. What we have to be careful of is that if this was negative 8, would I put negative 9 to the right? No, I would start going more negative in this direction. So you just be super careful when you've got negatives and you're making a number line that you put the negatives in the right direction. So what we did was we made a number line including that number that we were given, right? Here's our steps. Make the number line, including the number we are given in that inequality, right? In this case, it was 8. And now we just need to decide a couple of things. This is kind of a two-part number 2. We need to decide if our arrow is going to be going to the right or to the left. In this case, x could be anything that's greater than 8, so it has to be bigger. Our arrow is going to be going to the right. And then we have to decide if we're going to use that closed circle or the open circle around the 8. Could x actually equal 8? Not in this case. X has to be bigger, greater than 8. So we have to use an open circle right here. So it can't be 8, but it has to be greater than or bigger than 8. And then we're actually going to draw an arrow, make that line even thicker, and show that it's going to be anything greater than 8. So in my instructions, let's say, decide on, what did we decide? If it's going to be a closed or an open circle, decide on a closed or open circle. And if the arrow should go to the right or to the left, and which direction the arrow should go. Should go. You see that? Try and zoom in on those instructions for you so you can read it a little bit better. So those were our steps in terms of having to draw our own number line. So let's do a few where we practice drawing our own, and then a few where we practice just reading it off of a number line so that we can make sure we know how to associate an inequality with a number line. I'm going to move down where it says practice. We're going to graph these inequalities. Okay, so let's start with what we did before. Make the actual number line, including the number that we're given, this reference point of a 3. So I'm just going to put 3 in the middle, and since it's a whole number, let's just go ahead and count by ones. 2, 1. Okay, so we've got a number line. Looks like they're fairly evenly spaced. You don't have to get out a ruler, but try and make them as evenly spaced as possible. And our inequality tells us that x, whatever x is, has to be bigger than 3. So can it be 3? No, it has to be bigger than 3. So what kind of a circle are we going to use? That open circle. It does not include the 3. And if x is greater than 3, it could be 4, right? It could be 5. It could be anything this direction. So let's make our line really wide here and put our arrow this way. There is x is greater than 3. All right, number 2 over here. X is greater than or equal to 3. Well, it's going to look exactly like this, except what are we going to do instead of the open circle? It's going to be a closed circle because it could also be equal to 3. So I'll start with 3, kind of in my middle. Count by ones, those whole numbers. It could also be equal to 3, so it gets a closed circle, and it's anything that is 3 or above, because x is greater than or equal to 3. So there's our graph for this one. Okay, let's try number 3. X is, now this one is the other direction, less than or equal to 5.2. The alligator's eating the bigger number, so 5.2 is bigger. Now, this is a decimal, right? So we've got to do this maybe a little bit differently than we did with our whole numbers. Let's start by making a number line that at least includes that number, that point of reference, 5.2. Now, can I jump to just 6 over here in this case? Probably not. If I'm going to make evenly spaced intervals here, or increments, I probably should just go up by tenths. Maybe if this is 5.2, this could be 5.3, this could be 5.4, right? And then some down below it also, 5.1, and then maybe just 5 or 5.0. So we can certainly do number lines with decimals. We could do number lines with fractions as well. Now in this case we said that x, whatever x was less than or equal to 5.2. Could it be equal to 5.2? Yes, so we get a closed circle. It also is going to be less than that. So in this case we're going to the left. You'll notice that if x is first, then the way that the inequality is pointing is going to be the direction that your arrow is going to go, right? When it was pointing to the right, our arrow went to the right. Pointing to the left, arrow went to the left. And that's if x is first in our inequality. So let's see if we can try number 4. Number 4, it starts with a negative 2.8. X is less than negative 2.8. Okay, so we've got to be super careful here because this, now we've got negatives and we've got decimals. So if we've got negative 2.8 there, we want to finish our number line. This is negative, that means 0 is way over here. So if we're getting bigger than negative 2.8, this would be negative 2.7 is actually bigger, right? We're going to count down to get to 0 over here. Negative 2.6. If we're going smaller than that, negative 2.9, negative 3, right? And in this case it said x is less than negative 2.8. Could it be negative 2.8? No, it's not less than or equal to, so we have to use that open circle. And it said it could be anything less than that, so it could be negative 3, it could be negative 2.9, it could be negative 1,000,000, and it would work. So this direction. Okay, last 4 pretty quickly. These are recognizing the graphs. You don't have to graph it yourself, you just have to read it and say what the inequality is. So in this case, our x or z or whatever our variable is going to be greater than, larger than what? 4. Could it be 4? Nope, open circle, so it's going to be greater than 4. Means x could be anything in this direction. Okay, number 2, our x has to be, let's see, we're going to the left, so it's going to be less than 0, but couldn't it also be 0, that closed circle? So less than or equal to 0. Again, if x comes first, the arrow is going in the same direction as that inequality symbol. All right, this one has decimals. Negative 2.1 is kind of our point there where it's starting. So if it is, looks like it's greater than negative 2.1, not equal to, open circle. So our x has to be greater than negative 2.1, anything over in this direction. All right, and our last one. Oh, we've got some fractions here. Woohoo! We could also change these to decimals when we're making number lines. That's fine. Negative 3/2 is like negative 1.5, right? So it looks like it could be anything that is greater than or equal to this negative 3/2. X is greater than or equal to negative 3/2, right there. Okay, take a minute, do a few practice problems of these on your own to see if you can create your own graphs and match up some graphs of inequalities on your own, and then we'll do part 2 where we actually solve some equations, solve some inequalities using adding and subtracting.